A really common question type on the AP exam, both AB and BC calculus, has to do with the table of values. And oftentimes it is on both exams, but even if it's not in the free response, it'll be on the multiple choice. And you're given some information like f of x is a continuous differentiable function on the interval. Selected values are displayed in the table below. So you can see we've got the x values from 1 to 9. We got y values that range here. These are only certain values. Obviously, we don't know what's happening in between. First question often is estimate the value of the derivative or rate of change at 4. The easiest way to do estimating a rate of change is to pick the x values that are on either side of the value we're interested in and then find the slope between those two values. So these points are 3, 3, and 5, 7, and we simply find the slope between those. So the difference in the y's over the difference in the x's. So we've got 4 over 2, we've got 2. Oftentimes I would recommend just stopping right here, just writing that and being done. If they ask you, if there's some context to this and there are units, just say, figure out the units for the numerator, put that, and then divide it by, find the units for the denominator, if those things were asked about. All right, next, find the average rate of change of the function. Now, I'm going to kind of skip ahead here for 1 second because I wanted to point out that I asked right in a row here for the average rate of change, and right below that I asked for the average value. We have two averages that we talk about in calculus. One of those averages is a slope, and the other is a formula that's 1 over b minus a times the integral from a to b. It's a height of a rectangle type thing. It really depends what you've been given as to which average you're going to use. Now, I want to find the average rate of change for f of x. So you're saying I want to find the slope, the average slope of the function on this interval. This is a slope. This is us saying we are going to go to these points at the ends, 1, negative 4 at one end and 9, 9 at the other end, and simply find the slope between these 2 points. So the difference between my y's over the difference between my x's. Of course, you could just say 13 over 8. Again, I would have just stopped right here. But average rate of change is often a slope. The one caveat to that would be if we had been given the derivative up here, we've been given the rate of change and asked for the average, then we would use the one I'm going to use in the next problem, the average value. So essentially, I always say, are they asking me for the average of the function I was given, or are they asking me for the rate of change of the function I was given? And that dictates which average I use. If I've been given a function and asked for its average, I'm going to do this next step. So let me kind of put this formula in the margin here for a second. Put it up here. It's 1 over b minus a times the integral from a to b of a function. That is the average value. Okay. Now, I said using a left-hand Riemann sum with 4 subintervals. So let me just get rid of this work up here. I always think about this way. The first rectangle is going to go from 1 to 3, so its base is 2, and the height, the left side, sets the height on a left-hand sum, so negative 4. It's okay that it's negative. The next rectangle goes from 2 to 5, so the base is still 2, and let the left side set the height, so 2 times 3. Next one, base is 2, height is 7. And the last one, base is 2, height is 12. Now, this estimates the integral. So this estimates what I've done right here, the area from 1 to 9. So to do the average value, I, of course, would have to add this 1 over 9 minus 1 to the front of that. That's not part of the Riemann sum, but that's what makes it the average value. Okay. Now, I also made a note here that I wanted to also talk about the right-hand sum, midpoint, and trapezoid. So let me just kind of point out what I'm going to do here is I'm going to talk about how I could recalculate the area, kind of what I've just highlighted. Of course, this part out front, this 1 over 9 minus 1, this is the average value piece. This is not part of the Riemann sum. So my right-hand sum, the base, let me get rid of all of this stuff, the base will still be the same in that the first rectangle will go from 1 to 3, but now the right-hand y value sets the height. So that would be 2 times 3. And then we would go from 2 to 5 and let 7 the right-hand sum. I'm just going to fill in the rest of these. And again, you could put that, 1/8 out front, that 1 over b minus a, but the Riemann sum is what I've written in blue. Okay. Now, the midpoint is a little bit different in that we often use less intervals. In this case, we'll only use 2. Let me just point this out. What we do is we say the rectangle will go, in this case, from 1 to 5, but then we will use that middle y value to set the height of my rectangle. So the base is 4, and the height is 3. The next one goes from 5 to 9, and 12 is our height. So 4 times 12. And finally, a trapezoid. Now, the trapezoid, area of a trapezoid formula is this. Area, write this up here, 1/2 base 1 plus base 2 times the height. This is the area of a trapezoid. Now, for us, the bases are the y values. These are our bases. The reason for that, if you can think about like making a little graph of this, I'll get rid of this for a second. If you thought about making like a little graph of your points, you'd say, well, 1, -4, 3, 3, 5, 7. So maybe I'll draw this trapezoid. The trapezoid would look like this. So the parallel sides are the y values. So you always are going to do the two y values. So for this first trapezoid that would go between these two, we'd have 1/2 the two y values, so base 1 plus base 2, and then the height is simply how far apart they are. Well, they're 2 units apart from 1 to 3. The next trapezoid goes here. The two y values are 3 and 7, so 3 plus 7, and again, 2. The next trapezoid, I'm going to kind of run out of room here, I think, but goes between 5 and 7, so we got 1/2 base 1 plus base 2 times 2. And finally, my last trapezoid from 7 to 9 goes 1/2 base 1 plus base 2, and the height is always just how far apart they are, just the difference in those x values. Okay? You'll see textbooks that talk about simplifying that formula. I don't normally simplify it and pull a 1/2 out or anything, because to me, it makes more sense when you actually see each trapezoid. Okay? All right. Next, what is the minimum number of times that the derivative is 0 on that interval? Now, the derivative being 0 means there's a horizontal tangent. Oftentimes, that's a min or a max. So I want you to, in general, let's just think about what a sketch of what I've been given would look like. I've got something that starts at -4, goes to 3, goes to 7, goes to 12, then goes to 9, something like this. They said it was continuous and differentiable. So if there is a directional change up here and the function's definitely differentiable, I didn't have some kind of weird corner or cusp. So I would answer the minimum number of times is 1 time, because somewhere we had a maximum, probably, between, on the interval 5 to 9, and f is differentiable. Okay? All right, next up, I'm going to just erase some of this work so I can can see better. True or false? On the interval, there must be a spot, there must be a value, x equals c, so some x value, we're naming c, such that the derivative is 1/2. Well, to me, we've been told continuous differentiable, and then we're being told between 5 and 9, somewhere the derivative is 1/2. This, to me, feels like mean value theorem. So just as a review, mean value theorem says as long as a function is continuous and differentiable, which we were given, somewhere the average rate of change on the interval that we were given will be equal to the instantaneous rate of change or derivative. So if I were to find the average rate of change between 5 and 9, and let's just write those down quick. My points are 5, 7, and 9, 9. Well, the average rate of change, difference in y's over difference in x's, is 1/2. So f being continuous and differentiable, there must be a spot c, f prime of c, that's equal to that average rate of change. We should say must be a value. And again, this is mean value theorem, so that is true. Next, on the interval from 1 to 3, so now we're talking about this interval right down here, there must be a value where the value x equals c, so again, another x, such that the value of the function is 0. Well, you'll notice that this function went from -4 to 3. It's continuous, so it had to have crossed 0. This is going to be true. Now, the way I would write that, if this were like a free response or something, is I would say something like f is continuous. I would say that the value at 1 is -4, and the value at 3 is 3, and that the value you are asking me about is between those two y values, right? You're asking me, the question was asking me about 0. That's between -4 and 3. So by intermediate value theorem, there exists a c on the interval where f of c equals 0. Like that. Okay? Finally, true or false, on the interval from 1 to 9, there can only be one value such at x equals c. Well, in this case, the answer is false. And the reason it's false is because we have not been told anything about kind of intermediate values in between the y values we were given. We don't know what happened inside here. Okay? Now, if they had given us other information like the function was strictly increasing, which of course it wasn't because it went down at the end. But if they give us more information, we maybe could argue true, but we weren't given enough information in this to make that assumption. So these are, like I said, the most common things that are kind of asked about tables. Look for context to be added, and maybe they could add another word problem piece here or there. Make sure you know the way to kind of reason with your mean value theorem, that you find the average rate of change, and since the function's continuous and differentiable, there must be a value. I should have added on that interval. Let me just add that quick. On the interval from 1 to 9, or excuse me, 5 to 9, it was, where the derivative's equal to that average rate of change. Intermediate value theorem, make sure you state what the two y values were and that the y value you were asked about is in the middle. So there exists a spot on the interval. Yeah, just read the question carefully. If this helped you get ready for the AP exam, please like and subscribe. I have an entire playlist about calculus A, B, and BC. Good luck. Strive for 5.